Hello everyone. So today we'll be discussing this another problem, which is number of trailing zeros in factorial of a number n. So basically we need to tell how many trailing zeros would be there in factorial of n, right? So simple solution would be if I calculate the factorial of number n using either the iterative or recursive solution, then I count the number of zeros in the factorial by using the while logic, the iterative logic for finding out the number of digits in a number n, and then returning the answer. I would still get my answer, but if I consider the fact that the factorial of a number n grows very quickly, very exponentially, for example, uh, the factorial of 20 is 19 digit number, so it would be very hard for us to keep the number in bounds, right? So this won't be that efficient of a solution and won't work for bigger numbers, right? So let's talk about the efficient solution. So how do I get a trailing zero? Let's say I get a trailing zero by multiplying my number by 10, right? And how do I get 10? By multiplying 2 by 5, right? 2 into 5 is 10. So can I say that if I calculate the number of pairs, like if I can count somehow the number of pairs of 2 and 5 in the factorial of n, then I can have my answer, right? So for example, in this factorial of 5, if I calculate the number of pairs of 2 and 5 in its prime factorization, I would get my answer, right? And here I can write 4 as 2 into 2, like as its prime factors. So, and there's another observation, even I don't have to count for the pairs. So for example, here 1 into 2 into 3 into 4 into 5, I can say that for every even number there would be at least one prime factor of 2, and 5 would be repeating only after 5 numbers, for example 5, 10, 15, 20, 25, 30, right? So I can just count the number of 5s to get my answer, right? So I don't even have to count for the pairs. Anyways, 2 would be always greater than or at least equal to 5, the number of 5s in its prime factorization. So if I just count the number of 5s and the prime factorization of my factorial, then I would get my answer, right? And for getting the prime factorization, I don't even have to pre-calculate the factorial, and I can do that in a for loop or while loop or any loop, right? So yeah, this would be it for today's video, and thank you so much for watching this video, and please hit a like if you like it, subscribe to my channel if you like what I'm doing, and please leave comments if there are some suggestions or some doubts or anything you want to ask. Thank you so much.